meeting. And I'm going to be super quick since I think almost all of us are very accustomed to doing this now. But just in case you forgot, down at the bottom is a chat box if you want to make sure you don't forget your question, and Janine can call on you. Be sure and stay muted. If you ask a question, you can mute right after you ask it so that there isn't background noise, because that makes things difficult for folks to hear. So I think anything else, Janine, you want to make sure?
No, that's just fine. If you want to use the chat box, feel free to put your question there. I'll read it for you. Some folks feel more comfortable with that. Or if you would just like me to put you in the queue to be the next person to speak, I can do that as well. As you can tell, I'm the shyest person in the room.
Okay, so let me hand it over to Linda Kiefer, who has a very brief update. And Linda is our remedial project manager on the site.
Yes, so welcome everyone. And I wanted to put Dan Griffiths on the spot. There was a recent event that happened over at the site, and he had some information about that. So Dan, would you be able to call up? Do you need to call up your screen?
Yeah, I'll just share.
Oh, there
my
you
screen.
are.
Yeah. All right.
And so Dan Griffiths, he's with Parsons, and he'll be working on the site. We've been on for what, a couple months now, and we'll be on for quite a while after that.
Well, thanks, Linda. So just to make everybody aware, last night we had a grass fire at Lowry Landfill, and I put up a map so you can see the landfill, which is the crosshatch area. It's bounded on the south by Quincy Avenue and on the west by Gun Club. And the red outline that you see is the approximate burned area from the grass fire. The grass fire started sometime last night. Nobody really knows what time it started. It started on the north side of Quincy and then burned to the northeast and eventually covered that whole area. And I have a few photos that I can show as well. But the cause is unknown. The fire department was out this morning doing their preliminary investigation, and they were able to rule out electrical fire. There's no power lines on that side of the road, and no down lines. So there was no electrical fire causative. They're still unsure as to what started it. But when it was discovered, it was actually called in by a passerby, and then almost immediately after, somebody at the command post located on the north end up here saw it coming over the landfill mound and called the fire department, and they arrived on site and had the fire out pretty quickly. Minimal damage. The only damage was one of the flex hoses for one of the gas wells was melted, so it was easily replaced actually today. So I'll show you a couple pictures just so you can see what it looked like, as soon as I can figure out how to share that. All right, so this is just a picture from Quincy looking across the fence line at the fire, late last night. And just another view. This is actually up on top of the landfill looking down on one of the access roads. Fire department responding. They had it out pretty quickly within about 20 or 25 minutes of responding. And this is just a picture of the burned area. Well, part of the burned area. It mostly burned grass, but there was one gas well where the flex hose, the extraction line for the gas well was melted. So we replaced that this morning. And another view of the burned area up on top. So interesting incident at Lowry Landfill. That's about all I have. As things develop and as the fire department figures out what caused it, I'm sure we'll do an update sometime later on. But are there any questions or comments that I can take at this point?
Okay, no questions?
Well,
Okay.
Edith actually commented that there was a small fire there in October as well. Was that on the landfill though?
Yeah, the fire in October was actually caused by a bird, well, actually
That's
a
right.
flock of birds arcing across two power lines, and then the bird falling to the ground and starting a grass fire. So yeah, we had another one earlier this year.
Okay, hearing no questions.
Margie
Linda,
is
was there
thanking
any-
everyone. Go ahead.
Linda, was there anything else for your updates?
Yeah, so since it's been a short time since our last CAG meeting, I really don't have any updates. We're continuing to work on the conceptual site model and the containment system evaluations. And as I mentioned in the last meeting, I have requested that Diane McMillan and Lowry Wright give presentations at this meeting. EPA's contract with PWT and Tetra Tech ends in January. And so I would like to thank, and they're on the call, Bruce Peterman, Diane McMillan, Lowry Wright, Richard Peak, and Christy Schultz for all their contributions over the years. I mean, they've been a really great asset to the project, and we're going to miss them greatly. Unfortunately, our contracting is switched over to a whole different mechanism, so I'm not able to extend their contract, even though we had extended it several times in the past. So we're going to greatly miss them, and we really appreciate everything that they've done on this site. So the presentation that I asked Diane to do is an update on the draft for the conceptual site model. We did have a presentation from her earlier in the year, but because it's going to be going out for public review in the next couple months, and this is really our last opportunity to see some of the figures, get some information about it from Diane, and ask her questions. She'll be giving a presentation, and then after that, I asked Lowry to do a presentation on acetone and laboratory contaminants because that has come up as a topic in the past, and she's a great resource on laboratories, and I think she even worked on the PQL guidance for the state. So this is our last chance to ask her questions too. So I'm going to turn it over to Diane.
Thank you, Linda. I appreciate that. And it's been a lot of fun working on this one, so I'm going to miss it. I'm going to share my screen here. Hopefully you all can see it, correct?
Yes.
Okay. So in, I think, May of this year, I gave an update to the CAG on the conceptual site model. So I'm not going to go through a lot of that again. That May update was a lot of, what is a conceptual site model? Why are we doing it? Those kind of questions. So I'll provide a quick background of that information so you're refreshed. And then we'll talk about the current status and where we are in the preparation of the CSM. And then I'll go through an outline of what the document looks like. But really what I'm going to spend most of my time on is a tour of the figures and illustrations because it's the coolest part of the conceptual site model. And I think it's the most important part of telling the story of what is going on at the site and communicating that to you all. So the reason we are doing a conceptual site model goes back to the fourth 5-year review. Some of the recommendations in the 5-year review mention the need for a conceptual model that explained the current site conditions. And it's an important tool to communicate with you all and to communicate internally between different agencies and stakeholders. And it's also part of EPA's nationwide emphasis on what they call life cycle CSMs. So that means that, obviously the site is not the same as it was in the 1980s and the 1970s. A lot of work has been done. And so, their emphasis is on making a CSM a living document that is updated and refreshed as site conditions change. So the update to the CSM is being done as a joint effort between EPA and the WSDs. So we have a subcommittee that consists of Steve Fundingsland, who's with CDM Smith, who's a consultant for the WSDs, me, who is the consultant for EPA, and Sarah Teschner, who is the EPA geologist and hydrogeologist, is kind of the coordinator. So Steve Fundingsland and I did a lot of the work to put this together, and then the reviews back and forth between other EPA folks and other WSD experts. You know, we're working together to create this document. So the areas that are included in the CSM are the main landfill area, which we call Section 6, and I'll show you that. That's, you know, where most of the waste was disposed, or where the waste was disposed. And then goes on to Section 31, which is where the closed Denver Arapahoe disposal site landfill is. And then all the way and includes the north end area. I know you've gotten a lot of presentations from people over the last couple of months about the north end area, but that has been pulled into this CSM. So this conceptual site model should include all of the site. And then the data that we used for the update include historical data and reports. You know, it may be older information, but it's still very important to the understanding of the site. And also recent investigations and assessments. So, you know, I like to say there's very little in the CSM that should be new. It's kind of a compilation of all of the information that's at the site. So there wasn't a lot of original writing in this CSM, but it's great to pull all of it together and have something that is digestible, I think, to the stakeholders. So the current status, we did an initial draft CSM just in our subcommittee, and then gave it to others at EPA and the WSDs for their comments, which their initial comments have been incorporated. The revised version was sent out to CDPHE earlier this year. They are reviewing it now. And then once we receive their comments and any other additional comments from the team, we will send out a version that's available for public comment. So, you know, the red box here kind of shows you the updated schedule. There's going to be a 30-day public comment period in January, February of next year. And then we will take those comments, incorporate them, and finalize it in March. So just a brief outline of the conceptual site model, just to kind of give you an idea of the breadth of the CSM. And these are the actual sections in the document. So we talk about, you know, the introduction and purpose, the site location and setting from, you know, climate and rivers and surface water. We discuss the site history. There's obviously been a long history at the site from when waste began being disposed at the site in I think 66 all the way until now. The geology and hydrogeology, which is an important factor to consider when you're looking at the nature and extent of contamination, where contamination might go, how it will get there, when it will get there. So there's a robust discussion of geology and hydrogeology. And I'll go through some of that today too. Of course, the remedy components, there are many components to this remedy. The remedy for the site is containment. So the contamination is addressed through containment, monitoring, institutional controls. And so there is waste in place, which means that there is a robust system of groundwater extraction, hydraulic control, and monitoring associated with this site. We discussed the nature and extent of contamination. I think this has been kind of the bulk of what we've presented to you all in the last couple of months. We talk a lot about the plumes and the contamination. And of course, the contaminant fate and transport. So that talks about how you know, liquids that are in the waste can transfer into the soil, and then some of those liquids can transfer and dissolve into the groundwater. So how those different media, we call them media, you know, soil's a media, groundwater's a media, surface water's a media, how the waste can and the contamination can transfer between those media is a very important consideration for evaluating the site as a whole. And then I think most importantly, it kind of culminates in a discussion of the human health and ecological risks associated with this site. So the figures and illustrations, there are, what, 78 figures and illustrations. We went very heavy on showing you rather than writing it. Not that there's not a lot of writing, because oh my gosh, we did a lot of writing too. But pictures really are worth 1,000 words. So I'm not going to show you all 78. You know, they're all my children and I love them, but I narrowed it down to just a slim 28 figures to show you today. So I'll move through them really quickly, but I just wanted to give you an idea of all of the different types of figures and illustrations we pulled into this conceptual site model to really help you understand, help us communicate between each other, help us create a document that, you know, down the road, the next people will say, oh, that makes sense. So, I mean, it's everything from traditional traditional figures that we pulled in from like the RI and the ROD, geologic cross sections, the 3D images that I've showed you so many times, illustrations, and these are the really cool ones. Steve Funningsland did a lot of good illustrations of the site features, the remedy components, and all of the natural processes that are going on to help you understand what's happening. And we even pulled in conceptual design drawings and aerial photos, and then of course flow charts. I mean, it's a technical document, so we need flow charts. So I'm going to transfer over to the figures. Are there any questions before I start going through figures? I know I'm talking fast, but I only have a little bit of time and so much to tell you. Okay, I'll move on then to the conceptual site model as told through my 28 figures.
I'm sorry, Diane, I do have a couple questions.
Sure.
This is Bonnie. And when you talk about nothing new in the conceptual site model, does that mean that the MOLI will not be included?
No, the MOLI is discussed. And I think, you know, when I say nothing new, I don't mean like nothing recent. I guess I mean two separate things. There's nothing I would say maybe original. Everything that we talk about, like the MOLI, for example, is discussion and figures that are pulled from the MOLI report. Similarly, a discussion of risk in the North End is pulled from the North End risk assessment. So, you know, these are all pieces that you've seen before, but they're all put together into one narrative.
Okay, and one other question. When you say they talk about the liquids in the waste, is the anaerobic digestion of the trash that was added on top of the pits, is that breakdown and that pressure of liquids, is that also included in your analysis of in this CSM?
That is obviously a fate and transport of what's going on. I mean, methane generation within waste is definitely a common occurrence and is happening here. So yes, those kind of processes are discussed. There's a lot of information that was pulled from the ROD, which the record of decision in 1994 was possibly the last time there was a really thorough, comprehensive conceptual site model. It has been updated, you know, in pieces over the years, you know, most particularly in 2007 in the 5-year review that included an additional risk assessment and evaluation. But really, this is kind of the first time the CSM has been updated on a wider scale. But we do pull in a lot of information from the ROD because that info is still valid and it's still important to know about the site. So yes.
Okay,
so that's a long answer.
Okay, that's good to hear. Is there, I guess I'm asking, is there a discussion in this CSM of the breakdown of the trash that was put in and on top of these pits, and how the breakdown of that trash becoming liquid, how that can add to the movement of it? I'm not clear. I hear you saying that most of it was taken from the 1994 ROD, but all of that trash has been breaking down anaerobically for 30 years now. So is there some discussion of that breakdown and that additional amount of weight and liquid?
Well, subsurface liquids, which is I think what you're referring to, is an operable unit in and of itself. So, we'll kind of go through some at the very, very end, so you'd have to wait. But we talk about the OUs and the operable units that are based on the media, and that the liquid that was placed at the landfill and in the waste pits is a separate OU. So it is discussed as a separate media, and the fate and transport of it is discussed too. Now, what it seems like you're talking about maybe is the additional liquids over the years in terms of the solid breaking down. Not necessarily, and I don't think for this site it's necessary to quantify that, even if we could, because the remedy for the site is containment, that the monitoring and the containment of it already includes the OU of subsurface liquids. So, as the extraction systems remove, this contamination, there might be some additional from the bioremediation of the solids that adds more subsurface liquids, or maybe there is some infiltration from the surface, even though the cover is there to stop it. There might be some additional subsurface liquids, but the mass balance between it over the years, I don't think is too salient to what we're talking about in the CSM.
Thank you.
Okay.
Well, I have a
Anything
question
else?
as well. Yes, this is
Sure.
Margie Sobey.
Mhm.
And I may be wrong about this, so I will ask you to please correct me. But if I remember right, the last time we had a conceptual site model done, and you were not the one who did that, I don't believe, we discovered afterward that it was incorrect because it was saying there would be no contamination for at least 200 years, if ever. And we know that was not the case. So my question is there anything being done with this conceptual site model to try and avoid the very large error that was done in the last one?
Well, I mean, I'll kick the question about that previous calculation to somebody else, because as you said, I wasn't involved in that as well. But the conceptual site model does not include any independent analysis or modeling. If there has been, the modeling and analysis that has been done over the years is described in the conceptual site model, but the conceptual site model itself, these different documents and resources, and putting them together into a narrative. So, again, there's not original modeling or analysis in this document itself, but some of the north boundary barrier wall containment system evaluation, there's discussion of that and some of the methodology and assumptions. So it pulls in these other analyses, but this does not include anything new to you.
Karen Hancock has her hand up. Karen, do you have a comment or question?
Yes, thank you. And sorry, I'm having a lot of home internet issues right now. So I'm hoping that I keep coming in and out on different technology. But I was going to ask about your base map. The surface water, the two creeks, Murphy Creek and Tollgate Creek, it looks like those are enhanced, the color. And so I was wondering where those, where your stream alignment, it looks like you've have just the two that maybe been filled in with something. And I was just wondering if you could tell me where those alignments came from.
I don't know. Maybe is Steve Funningsland on the phone? I hate to put you on the spot, Steve. I don't know if you remember the base map that this comes from.
And I don't want to take up extra time. If maybe you could just follow up and after this and let me know where that comes from, I'd appreciate it.
Yeah, I don't see Steve in the meeting at all.
Okay. Well, I'll follow up with them. It looks like this was from a previous document And, you know, I know that they typically grab the backgrounds from, there are like websites, not like Google Earth, but a GIS layer that they grab from different resources. So I can look and see, you know, where this base is coming from.
Yeah, and it's not just the base map, it's the fact that there's the extra blue color that seems added. So I just wanted to make sure if you're using a base map or if somebody has enhanced that for visibility or something like that, that I understand where that comes from.
Well, I might be wrong, but I believe that that is some like a base figure that you get from these resources, and that Steve or I or anybody else doesn't add anything to it. What we put on top of it are these labels and you know, these labels. So it kind of comes already with the, you know, the green and the blue and the plats and stuff, and then we add the labels to it. And I think that's just a service that's provided, you know, for GIS figures.
Okay.
So I don't know if Steve has any control over that at all.
Okay, could you just verify that for me?
Sure.
Thanks. And which base map it comes from, which service?
Sure. Okay, anything else before I start going through?
Nothing more from chat.
Okay. So I was showing these initial figures first to show kind of the scope of the CSM, because I know that there were a lot of questions maybe a couple of months ago about, you know, is the CSM just going to be focused on the main landfill area, or is it also going to include the north end area? And the answer is it does include both. So it includes a lot of the area here and the site components. And then this is section 31 that I was discussing earlier, which includes, this is the closed DADS landfill, and then the rest of DADS goes off to the side there. And then just for reference, here is the Murphy Creek Golf Course, and the subdivision, and then Gun Club Estates, and the Highway 30 landfill. So basically our area is pretty much around East Mississippi to East Quincy down below. And then here's a figure showing the north end area and the 1,4-dioxane plume. We've had a lot of discussion about that, so I don't want to take up too much time going through that, but just wanted to show you that it was included in the CSM evaluation. And then, of course, we spend quite a bit of time on the remedy components that are on the Section 6 landfill, the actual landfill Superfund site. And this is a figure that kind of shows all of the layers and, I guess, points of interest on the site. So again, I'm going to be going through these so fast. I could spend an hour on each of these talking about all the minutia and all of the information, and we just really don't have the time. But I want to kind of give you a broad overview and then see if you have any, you know, systemic questions that I can answer before you read the document and get to study these in a lot more detail. So when we talk about the history of the site in section 3, we talk about the sources of contamination. So this is a figure that was from the 1994 ROD, and it talks about the source of contamination and the history of contamination at the site. So from about 1966 to about 1980, the landfill accepted both industrial waste and municipal waste. You know, and municipal waste is just your garbage from your home. And then starting in 1980, they limited it to just municipal waste and didn't accept industrial waste anymore. So in the early stages from 66 to 80, the way the waste was placed at the site was in these trenches and pits. So a trench was dug, they threw in the liquid and the solid waste and then covered it up. And then it was covered by a layer of refuse or trash, municipal waste, in this area here. And then there are other various sources of contamination. Also, there were tire piles, it's hard to say fast, asbestos, there was a lot of the sewage sludge disposal area, which is pretty gross, but there was land application of the sludge from the sewers. And so all of these are sources of contamination that were investigated in the ROD. And then, you know, we also have sources or information from the RI that was done in like 91, 92, that includes more detailed information on where the initial investigation occurred, the sampling that was done, and a little bit more of the documentation about where waste was placed and what type of waste it was. So with that, we were able to make some illustrations that showed you how this waste interacted with the environment there. So this is a schematic of the waste pits or trenches. This one represents one that was completed completely above the natural groundwater table, which is indicated here. These little triangles mean that that's where the groundwater is. And then this one depicts a trench that extends below and into the groundwater. So, I mean, as you can see, there isn't too much difference between them, except that the groundwater has a chance to mix within this trench. But there's still the liquid waste and the solid waste within the trench, and it disperses downward and creates the dissolved plumes. So. And then there was also illustrations of how the waste was placed on top of the land surface. And this kind of shows the different natural processes that happen to the waste, you know, how it's placed on the surface and then with day covers, you know, so there are layers of soil that were day covers, and how it would interact, the different mechanisms that it would interact with the natural environment. Again, this could be a long topic of conversation in and of itself. But a lot of the discussion that we added to the CSM that I think that you'll find really interesting, I know I did because I learned a lot doing this too. Steve put together these illustrations of the natural systems. And so this is kind of a macro, you know, a zoom out view of all of the natural systems that go on in the area, talking about the water cycle, precipitation and evaporation and uptake in the plants, you know, surface water flow, groundwater flow, and then all of the different ways that the lithology is built over the years. So there's a lot of technical terms that I learned that I was very interested, because I'm not a geologist or a hydrogeologist, but all of these processes are very integral to the understanding of the site. And I'll kind of go through a couple of them now. But I wanted to show you, we have a lot of these. One, because we have a lot of geologists and hydrogeologists, and they love these kind of things. And so they put in a lot of them. But two, you know, when we've talked over the last couple of months about the different lines of evidence, you know, why do we think the plume is where it is? And why are we confident that it's not over there instead of here? And these natural processes and how the soil was deposited and where it was deposited are those lines of evidence that tell us why we think the plume is where it is, and it's not just, you know, taking a left turn off to that direction. So I'll go through these a little bit. For example, sand channel deposits and bank erosions are one of the major reasons why we have a difference in like the soil type. So, you know, we have, I don't think this shows it, but this is like a floodplain deposit here. And then it shows kind of the process for this more permeable, coarser grained material, how it is deposited over the years in these areas. And this is important because it helps us understand flow path. So why is the groundwater flowing in some areas and not in others? And why is it, you know, not a continuous flow path? Why is it kind of spotty? Things like that. And I think that these kind of schematics give you an idea of some of the information that our geologists and hydrogeologists work with. And then we can kind of cross-check this with, you know, aerial photos and actual site documentation. So the surface expression of these things is one line of evidence that we have to say where we think groundwater flow would be most prevalent. It's not the only. I mean, you still have to look at the subsurface and take samples, but you can learn a lot from, you know, seeing what was going on at the site before waste was placed. So this is an aerial photo from, I think, 1965, and it shows some of the processes that we had kind of shown you in schematic form. And then one thing we also tried to do in the CSM is kind of give some more definition to some of the terms that we use often. I know you guys have heard a lot about weathering, you know, the weathered Dawson or the unweathered Dawson, but it's hard to kind of know what that means and digest it without pictures. So, you know, I think some of these concepts will hopefully be more clear, that you can kind of see how they affect groundwater flow. Like weathering, for example, weathering is kind of the breakdown of rock and minerals that is exposed to the atmosphere and to water and to microbiology in the near surface. So there is a limit, and you can see it in the bore logs. Like when you push a hole into the ground and you take the soil out, you can see color differentiation between the weathered and the unweathered. And this is important because that weathering mechanism, it's a physical and chemical mechanism, makes the weathered material more conducive to groundwater flow than the unweathered material. So, you know, that's an important concept to keep in mind, especially at this site where the weathered and the unweathered formation is so important.
Hey, Diane.
And this,
Oh,
yeah.
we have a question from Bonnie. Bonnie, go ahead. Unmute.
Yeah. Diane, I'm sorry, I tried to get in and couldn't get my system to work right a few pages back. Just a quick question. In the picture of the pits, those that were above water and those that were in the water, I noticed you have DNAPL listed, and the illustration makes it appear that the DNAPL is moving in the water. Is that correct?
Yeah, DNAPL would move on top of the water. So, you know, for people who maybe don't come to these often, NAPL is a non-aqueous phase liquid. So think of it like if you were pouring vegetable oil and water together in a cup, the vegetable oil would sit on top. So that would be a NAPL because it doesn't dissolve into the water. So some of the liquid would stay as a separate layer, and it would flow with the groundwater, but not dissolved in the groundwater, if that makes sense. So there would be a component that is dissolved with the groundwater, and then there's the DNAPL. And it moves with the water, but not the same as the water. Just the same as if you poured oil into your potted plant, it wouldn't work the same as if you use water in your plant. So
Okay, I appreciate that explanation. I was wondering because I know DNAPLs don't move easily, and that's one of the issues they had with the pits that they heated and tried to remove chemicals from. I know there was NAPL left in the bottom of those pits, and they said that it couldn't be taken out. So I'm just trying to compare that with what we're seeing here in these illustrations.
yeah, you're exactly right. I mean, there's mobile NAPL, which you can recover, but most of it is what we have here is residual NAPL, which just gets bound up into the soil, and it's so hard to get it to move, which is why, you know, increasing the heat in that area can kind of like make it a little more, can lower the viscosity and get it to move a little bit better. But you're totally right. It's hard to move NAPL.
Diane, let me clarify a little bit.
Sure.
Bonnie, you're right. The DNAPL is dense and the LNAPL is light. So in a DNAPL, it will tend to sink through water, whereas an LNAPL will tend to float on the water, like Diane was talking about. So with a DNAPL, it doesn't have a tendency to move with water. It tends to basically sink and get stuck into into your geologic formation. It'll migrate a little bit, but not very far. Whereas your LNAPL will. So your point is well taken. There's a difference in movement, whether it's a heavy NAPL or a light NAPL.
Okay, I appreciate that. I was just trying to clarify, because as I say, this illustration makes it look like that Napple's moving pretty easily. And, you know,
Right. No,
things I've
it's-
learned in the past, it doesn't do that. So I just wanted to clarify. Thank you, Diane.
You're absolutely right, Bonnie. DNAPL doesn't move very far.
I think I was here. Okay. This is kind of related to weathering too, and it kind of shows the difference. This is an attempt to kind of show the flow path that groundwater would take. And you can see, you know, in weathered Dawson sands, it's a lot easier for the groundwater to move. It doesn't have to go back and forth as much. It doesn't get hung up in the sedimentation between the particles like you would in an unweathered Dawson. And then the Denver sandstones are even tighter with more, and Tim, correct me if I'm wrong, I'm not a geologist, but the mineralization between the soil kind of blocks the groundwater flow. So you see it has to take a very circuitous route to get anywhere. So that's an important concept to talk about, how water flows through the subsurface. Another important concept is anisotropy, and this is something that we kind of talk about a little bit, but can be a confusing thing. So the difference between isotropic conditions and anisotropic conditions. So isotropic means that it's the same in every direction, and so if you have like a very coarse like gravel, you might expect a ratio. They talk about ratios of horizontal movement versus vertical movement. So from a practical standpoint, the measure of isotropy or anisotropy is how much it goes horizontally versus how much it would go vertically. I think if I'm remembering correctly, there was some calculation done in the RI that estimated that the anisotropy of the weathered unit was around 20-1, which means that it would go 20 feet horizontally before it would go 1 foot vertically. So it would be kind of a shallow angle. And then there was an estimate in the unweathered lower areas where it was 100-1, which means it would travel 100 feet horizontally before it would go 1 foot vertically. So those kind of flow differences in the different soil types are also very important to understanding how the groundwater moves in the subsurface, and therefore how the contamination moves in the subsurface. So how we investigate and communicate the soil and the surface to you is through a couple of different methods. So this is a very traditional classic cross-section, and what it does is when the geologist advances, like puts the soil borings into the ground, they remove the soil, and then they can study it and classify it as a coarse sand, a fine sand, or a silty clay. And then these kind of cross sections give you a lot of information. So this particular cross section is off of Yale Avenue. It's an east-west off of Yale, and it just provides a treasure trove of information. From here you can see the surface, the ground surface right here. You can see the groundwater level that has been detected in these monitoring wells. You can see each of these monitoring wells are these vertical lines here. The white is the screen interval. You can see where they contacted between the weathered and the unweathered lithology. And then they added information on like the 1,4-dioxane and TCE concentrations as well. So, cross sections like this are always used. They're a great source of information. So they provide a lot of data in a particular location. So we used these obviously, and then also used other techniques like 3D-VA to provide a little bit of information about a big area. So, they're kind of opposites. You don't get the kind of detail that the geologic cross-section gets, but you get a very large area and you get a good indication of what's going on in the entire site. So they're kind of different purposes and different tools, and then we're using them together to kind of give a holistic idea of the site. So this is the boundary between the weathered and the unweathered, so like the elevation. I think we've been over this quite a bit with the 3DVA, but I just kind of wanted to show it to you. And then, you know, we can get an idea of just focusing on the highest conductivity areas. So the most permeable stuff, we can kind of isolate and look at that. It still doesn't give you the same kind of detail that the cross section does, but it gives you kind of a bigger picture view. So they're both useful in their own way. And with that information, we can give you an illustration of the site geology from kind of a more cartoony focus, I guess. But this gives you a good understanding of how all of these systems interact, how you can see the fill material and the landfill material. These are discontinuous lenses of sandier soil that is interspersed with the more clay material. So, you know, there's a lot of different tools we can use to communicate geology and hydrogeology too. And then I'm moving into the remedy components. You know, starting, the site was listed on the National Priorities List in 1984. And almost immediately after that, I think in 84, in 84, the North Boundary Barrier Wall was installed. So the remedy component started even before the ROD was signed. So the ROD was signed in 1994. So there were interim actions such as the North Boundary Barrier Wall, which is still operating today, and other remedy components that were put in place in the 90s. And we have different schematics of these remedy components in the conceptual site model so that you can understand how they work, how they were constructed. I don't have all of them. There were quite a few of them, so I just chose a few to discuss today. But you know, there's information about all of them and how they were constructed and when they were constructed in the conceptual site model. So if the other landfill cross section was the before, this demonstrates the after, after the remedy was in place. And it shows the final landfill cover, the landfill gas wells that extract the methane that is produced by the decomposition of the waste, as Bonnie was saying, and also any like volatile components from the waste that is that might enter the pore spaces in the ground. And then talks about, you know, surface water runoff, and it is a barrier between receptors on the surface, like people or animals or plants, and the waste itself. So there's no interaction between those. So that's one component of the remedy. This is a diagram of the surface water removal action. And this was installed, I think, in 91 and 92. And it separates the dissolved groundwater plume with any stormwater that might come on the site. So this stops the rain from interacting with the contaminated groundwater underneath it. This is a diagram of the North Boundary Barrier Wall. So this was actually a conceptual design, and it shows, you know, some different materials used, how the North Boundary Barrier Wall works, you know, what it looks like if you could take a peek underground. This is a schematic of the North Toe extraction system, and this is kind of like looking at it from the side. So the landfill is over here and the North Boundary Barrier Wall is up here. So we're looking pretty much west, if that helps you. And this is, you know, a sump, and so you can see how the groundwater surface is depressed as you're extracting groundwater from this sump. I always kind of think of it as like when you're drinking a slushy or a shake through a straw, and if you suck really hard, it kind of dewaters a little area around it, and it takes a little bit of time for like the milk to come back into your area. So, you know, you could be like that kid that slurps it and makes a loud noise, you know, because you're sucking out faster than the groundwater comes in. So it kind of creates what we call kind of a cone of depression, or an area of depression of the groundwater as it captures here. And it's also important to notice that the North Toe extraction system extends all the way through this weathered portion. You know, as we were talking about, that's the soil that it is more conducive to groundwater flow than the unweathered soil. So that was designed for that purpose. And this is a profile of the MW38 sand channel system. And again, you can see the effect of the extraction wells on the groundwater surface. So this light blue one was from 2002, and then darker blue was after that. So you can see the effect that these extraction wells have on the groundwater in the area. And then, of course, another important component of the remedy are institutional controls. And these are administrative restrictions that cities and municipalities and other governments can put in place to prohibit certain activities at the site. One major example is because there are restrictions associated with the site, you can't build a daycare on top of the waste. I mean, it's kind of obvious nobody's going to want to build a daycare on the waste, but there are actual laws and restrictions that say that you cannot do that, and that protects that exposure pathway and those receptors. And there's quite a patchwork of institutional controls, and that is usually by design. You don't want to rely on just one restriction. It's a layered approach. So I know that's hard to see in this, but you can look a little closer at it when you review the document. I'm not going to talk too much about the nature and extent of contamination because I feel like this has been a topic that we've discussed a lot. But we do use 3DVA and some of the other plume maps and figures that you've seen, in Tim's presentations or in previous ones that show kind of where the plume is at the moment. So that was 1,4-dioxane, and this is the plume in 2018 of PCE and 1,1-dichloroethane, just to kind of give you an example of that. What I do want to spend time on today, because these can get a little bit complicated, and am I like going crazy over on time? I feel like I've been talking for like an hour.
Yeah, you're a little bit over. If you can start to wrap it up, it'd be good.
Yeah, I'm on my last one. So, this is kind of, as I said, the culmination of everything that we do on the site goes back to what is the risk to human health and the environment, including ecological receptors include, plants, animals, aquatic receptors like the fish and the algae and all that. So it's, people and the environment. So we put together these schematics that this is the simplest one, so I was going to kind of walk through this one, and then I'll show you real quick some of the others. But over here, we have the operable units. As I said, they're broken out by media, which is, landfill solids, landfill gas, shallow groundwater, subsurface liquids, deep water, surface water, soil, those types of things. So these operable units were identified, early on in the remedial investigations, and they've been carried through. So basically, in this one, we have landfill solids and landfill gas, because these are kind of the simplest ones to work through. On this side, these buttons here represent the different receptors. So we have current and future on-site industrial commercial workers, which are like the people who work at the Denver Arapahoe disposal site. Current and future off-site industrial workers, like the people who work at the golf course or the gas station, things like that. We have current and future on-site and off-site recreational users. And these are people who are, walking along the creek, potentially camping, using the golf course for golfing, for recreation. And then we have hypothetical future on-site residents. What if somebody built a house right on top of the landfill? And then current and future off-site residents, and then ecological receptors. So each of these lines represents a potential pathway from landfill solids to an on-site commercial industrial worker. And when these lines are solid, that means that there is a potentially complete pathway, which is then blocked by a remedy component that has been in place. So these X's mean that that pathway has been blocked by the remedy. And then there's text here that kind of describes, sorry, maybe I should go down to this one. Text that describes how that pathway has been blocked by the remedy. So for example, you know, let's talk about the building a home on the site. So you could accept the institutional controls prevent on-site use of the property. So that pathway has been blocked. And I should say that, you know, there are different assumptions of use that are associated with each of these receptors. Like, you know, for a recreational user, there are assumptions of how they might be exposed to the contamination. You don't expect a recreational user to dig a 6-foot deep hole and, you know, wallow around in it for a while. You expect a recreational user to be on the surface, to only be exposed to the surface soil, to the surface water, things like that, you know, versus a construction worker might be trenching through the area. So there are different exposure scenarios with each of these, and that's included in the risk assessment. And those, you know, will take a little bit of study. I think you'll really have to look at them and look at the remedy. But there are also, so this is the exposure pathway and risk assessment for operable units 1 and 6, which include the shallow groundwater, the subsurface liquids, and the deep groundwater. As you can see, there are no complete exposure pathways associated with these. However, as part of the North End investigation, there was a risk assessment that was done. So the results of that risk assessment are included in this box so that you can see what the calculated risk was if there was a hypothetical exposure pathway to these people. And then the final one is operable units 4 and 5, which is soil and sediments and surface water. Now this one does include completed exposure pathways, potentially complete exposure pathways for surface water. And then each time there was a potentially complete exposure pathway, we did a risk assessment associated with it to quantify the risks associated with that pathway. And same with surface water exposure for ecological receptors, like a deer could come and drink out of Murphy Creek, but what would that risk be to the deer? And then, you know, compared the concentrations that have been detected in that surface water with concentrations that would be unsafe for that deer. And then those conclusions are in the risk assessment, which, you know, long story short, the risks to deer are perfectly fine. The concentrations are well below documented hazards for mammals. So don't worry about the deer. That is the end of my presentation. I'm assuming there might be some questions, but I know I'm way over time. Sorry, I just get so excited about CSMs and figures and graphics.
Yeah, I have a question.
Sure.
Smargy Sobi, it's a curiosity. Most of these statements here have been hypothetical. And I kind of was wondering, you have a perfect opportunity to do some studies that are not hypothetical. They are real world. You could have actually monitored the deer and other wildlife at the site, including the raccoons that come over and stand on posts in Murphy Creek at the swimming pool before they fall over dead. You could have come to some of the homes and taken a look at homeowners' sump pumps and done an actual study. So I guess my question is, why is all of this hypothetical when you had perfect opportunities to do something real world?
Well, I want to just point out that my use of hypothetical on here is for future on-site residents. So that would be somebody building a house on top of the landfill itself. You know, I think what you're talking about are off-site residents, which we're not referring to as hypothetical in this sense. But your bigger question, I don't think that was your bigger question. Your bigger question is about the sampling and the analysis that was done. And I'll refer that to Linda instead. That's kind of beyond my purview.
And then I think David Berry, are you in the line?
Yes, I am.
Can you explain like what situations we would do as Margie classified it as a real world investigation or assessment versus a risk assessment like we have done on this site? Like what's the difference? Like how do we determine one over the other or both or?
Well, in the case of this particular site, the agency has, I think, determined that the exposures to wildlife out there are minimal. So they chose to not do what we would call a baseline ecological risk assessment that would involve things like toxicity testing and harvesting select species and looking for tissue levels and looking at populations to see if the population level is being affected. But I believe, and this is before my time, but I believe that a screening level ecological risk assessment was performed for the site, and it was deemed that a baseline ecological risk assessment was not indicated for this site.
Yeah, that sounds kind of convenient to me, but I thank you for the explanation.
Yes.
Okay, in the interest of time, I'm hoping we could move on to Lori Wright. We are a bit behind schedule. I want to make sure Bonnie gets her topics in here as well. Is that all right? Any super pressing questions? Okay, Lori, are you ready? And I think Janine needs to put something up. Oh, I guess we. Janine, are you there?
Just a minute.
Oh. There was a question from Dietrich.
Dietrich, did you want me to ask it? Dietrich asked, is the referenced SLERA limited to the site? Was it inclusive of the north end plume?
Thank you.
As far as I know, no, because the SLERA, I believe, was performed several years ago.
Okay, let's go ahead on then with Lori.
Can you see my screen?
Yep, we see common laboratory contaminants.
Very good. Lori, are you unmuted?
Can you hear me now?
Yes, we can hear you.
Okay, great. So thank you so much for giving me a few minutes of your time tonight. I know this has been a long meeting. What I was trying to bring up was some information about common laboratory contaminants. And actually you can move to the next screen because I'm going to power through this. So, all of a sudden I have a whole bunch of blank information here. But anyway, so what we did is PWT had pulled down all the acetone detections from 2010 to the present. Yep, just stay on the screen. And you're going to see a pie and pie chart. And so what we did is we pulled down the information of non-detections versus detections. And now the screen just disappeared.
But it's a lovely scene.
I think that's Janine's screen at the moment.
Yeah.
Yeah, I'm sharing the slides, but something has gone a little bonkers here.
Okay, well, I can kind of talk through it. So with the pie and pie chart, there you go. If you look over to the light blue Pac-Man or Pac-Woman or Pac-Person, you'll see that 82.8% of the analyses that were performed for volatile organics were non-detects. Okay, of that remaining that were actual detections, we broke it down a little farther, looking at groundwater, potable injection water, surface water, the treatment plant, and then actually air emissions. So are there any questions on this slide right here? Okay.
I have a question.
Yeah.
How old is this data?
It's from 2010 to present, so the last 10 years.
So it could be all from 2010. I'm just trying to understand, because a lot of times you guys show us old data that's not current and it's very confusing.
I apologize for that if that has ever happened before. I do have the raw backup data that I can share with Linda, and she can share with y'all.
Well, you understand that we don't think the site today is like it was in 2010, obviously. So it kind of.
Okay. I thought 2010 to present in the, the last 10 years would have been a good database to work from.
Well, I'm not meaning to stop the presentation. Go ahead. I'm just curious about how current it is.
Okay. Not a problem. I understand. And so here's the breakdown from that pie and pie chart of everything we saw. And I'm dealing with acetone mainly because it's a common laboratory contaminant. I've worked in a laboratory, and as Linda mentioned, I was also on the direct, gosh, what would they call it? The overseer of the PQL regulation, which became, I think, actually, I want to say the guidance document, Reg 31 or 61. And this is something that we ran into a lot with having laboratory contaminants showing up as actual contaminants of concern at different sites. So acetone is one of them. Another one would be your phthalate esters, which would show up as semi-volatile organics. And these are typical plasticizers used in the field and in labs. And then also BTACs, which is benzene, toluene, ethylbenzene, and xylenes, which show up as contaminants in the field when you are working near a site that has a lot of traffic or a generator. But we just picked acetone as our test subject for this one. And then Janine, if you wouldn't mind forwarding on to the next one. If you can. Okay, so right here, and I want to let you all know that this is a logarithmic scale. So you're going to see on the left side, micrograms per liter, and you see 10, 100, 1,000, 10,000. And I'm put up this slide mainly because if you make it on a total on a scale where you just had 0 to 100,000, you would not be able to see how low level it is. So if you look down at the bottom here, and going across are all the well numbers, and I know it's hard to see, but everything is around 10 parts per billion, which is typically considered background. And the question had been brought up before about whether or not acetone was used in labs anymore. And I can say, working in a laboratory, yes, we used acetone a lot. It worked really well to take off Sharpie marker off of beakers. And then you'll see that there is one outlier that I identified at 190 parts per billion, but please take a look. The state standard is 6,300 parts per billion for groundwater protection. So that's where the red line is represented, and it is well below that. And so this is all the data, and what these are, by the way, are maximum values. They are not averages. They are maximum that was ever detected at that well in the last 10 years. So 190 was the highest, that's parts per billion, that we ever found of all the data that we were able to migrate from the database. Are there any questions on this graph that I can help answer?
Yeah, I have a question.
Yes.
You made the statement that all of the data you were able to, I think you said, migrate from the database. Does that mean there was some data that you couldn't bring across?
No, I only migrated everything from 2010 to present. All this data is available in Scribe, which is an EPA accessible database. And everything has been migrated to that database and is accessible to the public. PWT did do this effort, and we pulled everything we can over there. And we also have been updating based on Parsons' regular updates of data. And my thanks to Bruce Peterman, Richard McPeak, who made this effort happen. I also want to say thank you to Linda and Sarah, since this is the last presentation I'm ever going to be able to make. And again, to Dustin, Janine, and actually, Tim Shangra, are you online?
I am.
Okay, so could you tell me a little bit about the data validation you guys go through? Because I think this would really help everyone understand how much work goes into validating data that is presented.
Sure. Excuse me. Maybe a point of clarification. There's what you've shown in this data slide is a combination of non-detects and detects, correct?
That is correct. I did not clarify between J's, and as you know, that's estimated values.
And blanks.
Yes.
So there's when a water sample is received from the laboratory, there's an analytical report that comes along with it. And the report will identify whether there was blank contamination. So if there's a sample that basically is a blank sample, and it contains acetone, then there's always a qualifier that says, yeah, be careful with this because we're seeing this in the blank. And there's also qualifiers to whether the data were arrived late, you were out of holding times, and if that case, the qualifier of an R or reject is applied. But back to your point, in terms of validation, 10% of all the data, of all the water quality samples that are received by the laboratory is validated. So what we will do is go through an extensive evaluation of the laboratory blank samples, the method blank samples, and see if there are contaminants such as acetone in those blanks. And I talked to Lynn, who is our data validator, Lynn Brill, and the answer is most of the samples that contain acetone are also appears in the blanks. So to Lori's point, don't be surprised if you see acetone, in the analytic results. It's because more than likely it's a laboratory contamination, especially if it's at these low levels. So anyway, bottom line is that the data are examined for quality purposes before we even consider them in the data evaluation for whatever usability the scientist is going to be using the data for.
We have a question from Sonia. She's asking, can Lori in particular,
Yes.
if this is contained, this information is contained in a report or review that you'll be sharing with the CAG, including a short statement of why this is important to the site status understanding?
This information will be provided to Linda. And I do believe that this presentation is going to be made public, correct, Janine?
I'm sorry? You were asking me what she said? Yeah, she wanted to know if there was going to be a report, if there is a report, is this information in a report somewhere? Or a review that you could share with them, with the CAG?
You can have this presentation. I'd be more than happy to share that. Otherwise, the information is available in a Scribe database, and all of Parsons' data is available also. It's an access database.
Is this something that the public can access?
Yes, anybody can access Scribe.
Well, the data, all the data are included in each of the SSRs.
I was going to say that's, yeah, go ahead.
Right.
So yes, the data's there, and it's actually, there are links all over the place for them. That would just require them to actually take a look at it. But right. There's no, so there's, as far as the report itself, it summarizes it too, right? Each of the reports, the SSRs?
No, well, the SSRs have data validation reports in each one.
Right.
And this is for the 10% of the data that are validated, but they don't contain this kind of a summary that Lori just put together.
Right. Okay, so then can we wrap it around back up to the beginning of why it is important, this discussion, this concept is important to understanding the site status?
Okay, why it is important is to let people know that you have backgrounds of different organic compounds that can come from the laboratory or from field operations, and don't necessarily say that there is a problem at the site. So when you're looking at this chart, you'll see 10 parts per billion. And if anyone has ever used nail polish remover, you're getting more exposure from that than you are from this background concentration.
Does that
I don't know if I've...
yeah, does that make sense, Sonia?
Yeah, does that make it clear? I mean, 10 parts per billion.
Hi. Yes. Can you list for us which chemicals are listed in your review so we know which ones are likely to be background chemicals that are of concern?
Okay. So anyway, we only looked for acetone because that's a common laboratory contaminant. There's also, benzene, toluene, ethylbenzene, and xylenes will come from contamination if you're working near a generator or a highway. Methyl, ethyl ketone, methyl isobutyl ketone. There's a couple others. Phthalate esters, they're used in a lot of filtration devices in the field, and you can get positive hits on those for semi-volatile organics. And I'm more than happy, I can add it to the slide. The initial slide, I can put in common laboratory and field contaminants. And Linda did provide me with a couple of links, and so did Diane, of common contaminants that are going to show up. And just the whole thing is, these are going to be at the part per billion level. And don't know where to go with this one. So I've worked on a couple sites where we've had these very, very low contaminant levels, which took us into a whole risk assessment process. So what I was trying to get across with this presentation is that there are common contaminants that you are going to find in almost everything you test. And I want you not to be afraid about it. Just realize that they are there. And this is an exercise we did on behalf of EPA to pull out this information to provide everyone just kind of a big overview of, okay, here's acetone. And you know, if you've ever done any kind of woodworking, you have been exposed to acetone. And I'm trying to show you information that provides you with maybe a little bit of confidence that these low levels are due to laboratory contamination, maybe due to field contamination, because I've worked in the field for a good 14 years, and I did find that we would get contaminations in the laboratory supplied blanks, and we had contamination of different compounds in those blanks. Could it be due to the water they used to send us? Could it be due to the coolers that maybe were used for a hazardous waste shipment the time before?
So to answer your question, Sonia, about a list, there would be a list in those SSRs, correct, Tim?
Not necessarily. We don't. If during the data validation process we identify a compound existing in a blank, then yes, then they are qualified. But in terms of a list of all the possible laboratory contaminants that I think Sonia is asking for, we don't include that.
Now, Sonia, is that what you're asking for, is laboratory contaminants? Or are you talking about contaminants in general being sampled for in the with respect to Lowry landfill? Where'd she go? Sonia?
Well,
Oh, there you go.
And if I can add one more thing is other laboratory contaminants can be metals, such zinc is very, very common. Aluminum is another one.
Hi, sorry. Thank you. So yes, my question, I wasn't very clear, I suppose. My concern was why we're getting this presentation. Is acetone a particular concern at this point in our understanding of what's going on with understanding results for Lowry landfill? Are there other background chemicals we should be, wary of? But basically trying to understand this presentation, why are we being alerted to this at this time, I guess is my question.
So this is Linda Kiefer. So I mean, I can answer that. So it's twofold. One is I noticed that in the handouts for this meeting, there was an inclusion of a spreadsheet with some chemicals that were listed on there. And so I thought this would be a good time to explain that sometimes we do get hits on chemicals that are laboratory contaminants or field contaminants. And then the second part is Lowry is an expert on this. And so this is really our last time to be able to present that information to you from her and answer any questions that you had. So it's twofold for that. And I just know of, I've been working recently for the last 2 years on this site, and this acetone question has come up. We're seeing acetone in these samples. Why is it there? What does it mean? And so this is the most likely explanation, is that it's a laboratory chemical. So, we can put together Lowry's slides and then, cite some references and add some information. So it would just be like a mini report for you.
Okay, guys.
To kind of pull it together. So anyway, sorry to take so long, but.
Okay, guys, this is Bonnie. And I need to ask if there's anybody else that has a question. We have been given an hour to talk and we now don't have it. And I would like to have some time here to discuss. I see Commissioner Baker has to leave, and he's an important part of this discussion, and some of the residents have some questions. So can we please move on to what we were doing, what we were going to do earlier? And that is to have the issues that are on the agenda from the CAG group talked about. Can we do that?
Absolutely.
Thank you. Sonia, don't mean to interrupt you. I'm sorry. I understand now what Linda was trying to accomplish. I sent a spreadsheet that was out of the North End study. It came from Lowry, showing that there are chemicals of interest and chemicals of concern that can be found in the water. But if they're below standards, then no one has to tell us about that in the testing. And the only reason we did that is I'm not afraid of acetone. I'm not afraid of things. What it is that we know that there are things below standards in the water that are in the groundwater. And the point is we don't want them swirling around our basements. It's just that simple. And we don't know exactly what's there. We're not saying we're afraid right now or anything. So hopefully I need to move on with this because we wrote a letter. As you're all aware, we were invited to a special study session with the city of Aurora. It was the first time in 40 years, folks, that we've ever been invited to come and talk to the city council directly. We're always able to go and comment, but it generally is met with silence, and we don't think they look at our information half the time. And so we took this opportunity, and we're very thankful for it. We're thankful for Mike Kaufman and Nicole Johnston allowing us to come. And we did not expect Denver and Waste Management to be a part of it. It's not that we're concerned about it. It's just that it kind of was a shock that all of a sudden they were on the agenda too. And so we did send a letter of thanks to Mayor Kaufman and to then Pro Tem Mayor Nicole Johnston. And the reason that this is important is because I think it upset some people that we did send this letter out, but I have to explain to everybody, the reason that we sent this letter out is because this was a public meeting. And this was a meeting at which we were asked a question that we've been asked, I can't tell you how many times, by City Council. Well, no one's drinking the water, so what is your concern? There's nothing to be concerned about. And number one, it was very shocking to the CAG group to hear that said again, knowing that there are people to the north who do drink that water. And the answer that we've always tried to get back to them is that my name is not no one. And the other people drinking the water to the north, we don't know that the water is or is not contaminated, but we do know because we've seen the contamination rolling down Murphy Creek in the past. So we do know it does go that way. And so this meeting was very important to us, and to have one of the council members say during the meeting, well, I went and met with the health department on February 13th, and they told me that only one aquifer was impacted. And so that's why we wrote our letter. And it was very, very important to us to write this letter because we were challenged publicly. And this CAG gets challenged constantly. And so the problem that we see with all of our communications for the past 30 years is that the communication is limited. Everybody has their own little section of communicating. It's WSDs and EPA, CDPHE and EPA, and everything's kept right in those little circles. And what happens is that we never get a chance to get the concerns the community has out in the public where we're actually talking about them and we're giving some concern. And one of the biggest examples I can give you is that when the steering committee, Lowry Landfill Steering Committee was formed, I called the WSD's PR firm, and I think at that time it was Intermountain or something, but I spoke with the woman at that PR firm. She was helping to get this Lowry Landfill Superfund Site Steering Committee started, and I asked her, can the community come to these meetings? And she said, no, this isn't conducive to the community being involved. It's about development. And so I explained to her that we're very concerned about development in the area. And she denied me having any access. And I know for a fact that EPA and the state both asked at the next meetings where Lowry was being discussed, shouldn't the citizens be involved in this discussion? And so as a result, it's our opinion that one of the reasons that we're so far down the road all these years later is that because we were not included in the discussion to raise our concerns about the plume and a few other things that are now very evident, it was never talked about until now. And so now we have a lot of upset and uproar. And what we're saying is this just shows that we really should not be doing anything that would make us lose our focus on why we need to talk with each other and why the public needs to be involved. So number one, I want to thank Tracy White for sending out the response that she did. I do want to say that we are disappointed that Mr. Putnam didn't want to respond and sign his name to it. We're having the same issues with a lot with EPA as well. I don't know why the managers and division directors, you know, this site, the attorneys, I've asked for letters to be signed by EPA attorneys and we can't get that. So I'm just saying to you that this lack of communication between us all has been what's caused a lot of our problems. So now we have a letter from the CDPHE and we do appreciate that. But I have to give Margie and Paula and Sonia an opportunity here to give you their response to the letter. And that way, Colleen, maybe we can talk with you a little bit about this after you've heard what they have to say. But we believe communication needs to carry on and needs to get better at this site so that we can have the right information at the right time. So Sonia, would you like to give your impression of the letter that we received back?
Yes, thank you. I wanted to point out that with regard to the letter, it states, I want to assure you that CDPHE technical staff assigned to Lowry Landfill possesses a thorough understanding of the site's complex technical issues. And of course, we're very well aware of that and we appreciate that. But what we wanted to make sure is that in the response, we were hoping for a very clear response regarding the contamination of the aquifers. And we were hoping that CDPHE would demonstrate their vast technical awareness and, interaction with the site in order to specifically state which aquifers were contaminated. That was the point of contention. And we wanted that to be specifically stated because we want our elected officials to be able to look at that and see that acknowledgement in writing, because they don't tend to believe information presented directly by the CAG. So we were looking for a very concise statement from CDPHE on that regard, and are hoping that that will still be forthcoming regarding contamination of the aquifers, which ones and what the evidence is. Thank you.
Hey, Margie?
Yes, I guess I will echo, excuse me, what Sonia said, but I will also add that to me, that response was, and I apologize, Linda, for saying this, but it was very similar to the 3-page letter I got from you a year or so ago when all I wanted was a yes or a no response. And I felt like CDPHE did not address the issue at hand and never really gave us a clear answer, as what Sonia said. And so when I read the letter, they talked about this has contributed to confusion. And I thought, well, whose confusion are they talking about? Was it the council members' confusion? Was it the CAG's confusion? Whose confusion were they talking about? So to me, it was, it just didn't meet the mark.
Thank you, Margie. Paula Smolin, can you give your impression of the letter?
Yes. Regarding the letter response from CDPHE dated on December the 3rd addressing Bonnie Rader's letter to Mr. Putnam, I see no commentary noted that was offered to Councilman Marcano to clarify to him during your meeting that there were at least 4 aquifers potentially involved in the contamination concerns. It is not surprising that he would come away with the assumption that because the Denver aquifer is not mentioned specifically, that there's no contamination there. I believe we have some evidence that there is contamination in that aquifer from wells 141 and 142. This is a serious example of incorrect communication that flows from the agencies involved. The potential result of such miscommunication or omitted information can mean that the city of Aurora will make decisions that affect development in that region of the site when those decisions bear serious consequences for future residents and the city's liability. It is your responsibility, EPA and CDPHE, to provide accurate and complete information either directly to the public and to those that you meet with who will make public statements. And it is our responsibility as CAG to give the communities affected the very best, up-to-date, true information that we've gained through you and our technical advisors. And parenthetically, I would like to point out that Dietrich McGinnis is Dr. Dietrich McGinnis, not Mr. Dietrich McGinnis. And I wish that correction to carry forth on all the further communication. Finally, the CAG is weary of being treated as though we have limited understanding of this entire Superfund site and the threat of contamination that flows into our communities. We are a vital source of information to the public and the necessary challenging counterbalance to the agencies that Councilman Gruber and others say is their decision-making source. We wish to be part of that decision-making source, and we will not rest. Thank you.
Thank you, Paula.
Bonnie, I'd like to say something. Would that be all right?
Okay.
This is
Go
John
ahead.
Barber.
Sure.
I think the summation of what you're hearing here from the last three people that spoke is it not the CAG's responsibility to police this site? Yet we are the ones that are always policing the site. We are the ones that are culling through the data and finding things and asking questions. And we don't get direct answers. We just get, well, there's data gaps, and then we get old information, and we got to do some more research, and we just never really get direct information to pass along to the communities that we represent. And so then the trust breaks down because we're always having to be on the hunt, always having to be on the look. And then when we bring something up, we never get a direct answer. And I think this is kind of the summation of what you're hearing here, is that why do we police? We should come to these meetings. Like the meeting I went to, I mentioned before, like the meeting we went to with the Buckley Air Force Base. It was really clear. That gal talked for an hour and nobody had any questions because she was very forthcoming, very transparent about the issues, the concerns, contaminants, what they're doing, how long it's going to take care of them. It was all clear. We never get that here. We just get the constant merry-go-round push. And we constantly get educated, like most of today's meeting was, educated. And there's not really productive dialogue. Thank you.
Okay, John, anybody else have something they'd like to say on the CAG? Okay.
Yes, if I
Go
could
ahead.
just, sorry,
Go ahead.
if I could just follow up, I would just like to specifically request from CDPHE a more concise response regarding the contamination of the aquifers. So it's in clear, plain language, what's known about contamination of which aquifers that we can share and should be shared with Aurora City Council members and staff. Thank you.
Okay, thank you, Sonia. If everybody on the CAG board has had time to fill in the health department, Colleen, I hope that you and Dustin understand our purpose in sending our letter to Mr. Putnam. As I said, it was a public meeting. We had people there that have been challenging the CAG, challenging the public on their concerns, and we have to prove everything that we do. And we felt that this opportunity was something we couldn't let pass, with one of the council members saying that the health department gave him different information. And I from the letter, I'm thinking that maybe Councilman Marcano misunderstood the issues, and that's what I got from the letter. But I've been reading these government letters for a long time, and so I think I saw a little bit more there than the others did. But I appreciate their perspective because it's very important. It's some more of where we need to go as a communication. And so I do hope that this will help the EPA and the state understand where the CAG is looking to go with this. So, Colleen?
Yeah, thank you, Bonnie. And I appreciate getting, somebody, if everybody can mute, because I'm getting feedback. So I appreciate the perspective. When we received the letter, our biggest concern was trying to make it clear that we didn't provide any incorrect information to the councilman. And let me give you a kind of a background on how that meeting came about. The councilman reached out to us because he had some specific questions about redevelopment north of the site. And so we met with him, and the meeting was really not set up where CDPHE gave a presentation on the background and all of that. We strictly answered his questions as he posed them to us. And so any discussion in that meeting was really limited to his questions and how to answer his questions and his follow-up questions. It was our understanding that he had done quite a bit of research on his own about the site. He had spoken to other entities even before he met with us. And so our discussions were very limited, and again, only to the development of areas that he was asking questions about. So we did not provide a comprehensive background on the site or a comprehensive discussion of site-wide contamination. We were really just talking about impacts in the north end and potential impacts on development. So to the extent that, he asked us questions and we provided information, we believe that information was accurate. But the intent of the meeting was not to provide a broad background on the site. And so, if that was what he was seeking, we would have done it in a different way. But I do appreciate you clarifying sort of what you were looking for. We were trying to balance getting a response to you so that we could clear the record about, the meeting with the councilman, and understanding that the request was sent to John Putnam, who really knows nothing about the site. And if we wanted to do a more deep dive to respond to, what you're asking for tonight, it's not something that John Putnam would have the ability to do. That really needs to come out of the work that Dustin and I do. And so that'll just take a little bit longer. So we can certainly get together and pull something more comprehensive together for you based on what we heard tonight.
And I still haven't heard tonight what the answer is, where the contamination of the aquifers resides. For me personally, I have not heard that.
Well, again, Margie, we were focused just on the north end. So the north end, the only aquifer that is impacted is the Denver. And that's all that we discussed with the councilman, was that area. So the bigger picture of contamination under Section 6, where we're talking multiple aquifers, it's not the same discussion we were having with the councilman. We were strictly talking about the north end, and the Dawson doesn't exist in the north end. So we were only talking about the Denver. And that's what we were trying to get across, that we never got into the multiple aquifer issue that really exists further south under the landfill. We were only talking about groundwater in that north area, and that's really just the Denver.
Okay, and that is certainly much clearer than what I saw in the letter. Thank you very much for that.
You're welcome.
Well, we had, if I could just add, we had just what you had in your letter, which came from what you heard at the council meeting. And there, we've had to piece it together too. It was a very specific reference to a meeting on February 13th. We didn't meet with the councilman on February 13th. And it seems like a really kind of minor point, but what Colleen said was, when Councilman Marcano came into the room with us and we met, he had already done a lot of homework and had multiple conversations before we got there. So this was a few weeks after the 13th. So, all of us kind of scratched our head and said, well, where did that come from? We don't know. It's a mystery. But because of the conversation we're having here and what Colleen just said, we'll put that in writing for you. That's our understanding where the contamination is. But that's not what we talked about with the councilman per se. It was all over the place, and he had his own agenda. So, what do you do? You talk to the man. So that's
well, that's right. And I appreciate that, Janine. Thank you. And I do understand. I got February 13th off of I went back and watched the meeting. And I thought he said February 13th. If I misunderstood him, then I need to apologize, but that's what I heard. Now, I'd like to get back to the fact of us sending it to the division director. The reason we did that is because I think you're all well aware, those of you at the health department, how upsetting it was to us when the whole hazardous materials division just was gone and all new people came in. And that is no slam against any of you, because you're working hard, you're good scientists. The issue is that anytime something comes up now, it's really hard because you don't know the history, you don't know the background, and we wanted the division director to understand that this was the result of his decision to make this major change. I mean, the whole division was changed. This is just really hard for the public to deal with.
Bonnie, can I clarify that? So
Yes.
the decision was actually Tracy White's, and she's the program manager. The decision wasn't made above her head. That was Tracy's decision to change the project manager. And the only real change was Lee Pavanka. It was not the entire division. Janine's still involved. It switched over to my unit because it switched to Dustin. And then Wendy Noggle retired. So Wendy was involved until she retired. So it really just was one individual in the division that the switch was made. So, and it was Tracy White. So that really is an issue that, you know, she responded to in the letter because that was her decision.
Okay, that's good information. You've clarified that. But, you know, Doug Jameson's gone. Lee Pavanka's gone, no longer working with us. And I know Jennifer left a long time ago, but the point is, we don't have the same people that we were working with when we were putting all of our issues together to present to the state to say, here's what our concerns are. And so Doug Jameson finally understood, you know, and Wendy Noggle, she retired, but she came back to help. And so we were hopeful that would happen some more. So that's what we mean by the entire division changed. And I understand what you're saying, and I appreciate and thank you for straightening that out for us.
You're welcome.
I think we should also, while we're talking about lack of continuity, is how many times have we seen a change in the EPA over the site, even in the last 3 years?
Okay.
I believe are we on the third person from the EPA since we started this CAG? Is Linda the third person?
Well, you mean because Rebecca and Steve were there first, and then
yeah.
Well,
no.
Well, then there was Les too.
Les Sims was first, yeah.
Yeah.
And
I'm just saying that
Rebecca was never a project manager on this. She's always been management. She was management. Love her.
Well, she was wonderful to work with, and we miss her.
She's the only one that I understood. Thank you.
Okay, so bye-bye, kids. Dietrich, you said you had a question about the acetone?
Yeah, thanks for taking a second for it. I guess I just, you know, I'm a little concerned because usually when you get to talk about quality assurance, we actually see some quality assurance data. I'm happy that we did present that we aren't looking at levels that would cause issue with toxicity, but it's more of a good indicator. Are we eventually going to see those data points combined with what you find in background? Are you finding acetone in background with each one of those points at those concentrations? I mean, it didn't make a lot of sense to look at the occurrence of acetone, particularly since it could be associated with the waste that was disposed there. But we didn't see actual, I mean, you guys run background in both field and laboratory at 5% or more. You can quantify if you have a contamination problem, but we never saw that quantification.
Hey, Dietrich, it's Lowry, your lab girl. So ask me what you want and I can try to help you out.
Real simple. I would love to see your data presented with the associated background wells, the background field and laboratory blank results for those associated samples, for those batches.
Okay, well, it's all available publicly.
Do I have that level of quality assurance database?
If you look at it, they have 3 different columns. One, has it been validated? Yes, it has been. And third, we accepted the data validation.
What we need to see is the concentration of acetone in your blanks. Otherwise, we're just looking at the occurrence of acetone on the site. There's a difference.
Oh, yeah, there's definitely a difference, but
we can't assume
like I said, it's publicly available.
So you just told me that the data flags are publicly available. My question is, and can anybody answer this? Is there a database that actually has your QA/QC results that we can,
Yes.
okay. Is it a database of paper reports, or is it something that we can put together with the data that we're evaluating? Because I think you showed a pretty significant occurrence of acetal. I would think you'd want to get to the bottom of that, and quantifying it by comparing it to the actual field and laboratory blanks, all of a sudden looks a little more important.
Well, all I'm saying is I get a pink slip on January 12th. I don't know if you do.
Well, that's beside the point. I think the work settling defendants would be interested in getting to the bottom of this. This implies the quality of their laboratory services.
Dietrich, why don't you send me an email of exactly what you're interested in, and then we'll get that information over to you.
I appreciate it. I'll send a request through Bonnie.
Okay, sounds great.
I want to thank Dr. McGinnis for bringing this up, because what I got out of this was, hey, we found some commonly occurring chemicals that sometimes show up in lab reports and lab tests. And basically it was a sleight of hand. Look over here. This is what's commonly occurs and is not a big deal. We're just telling you about it. That's the only point I could see from that presentation. So I thank you very much for calling attention to it, that it was you got something different from it. Thank you.
All I can say is I'm insulted.
I would like to say, though, one of the important facts is we're not looking at this as adding to the toxicity of the plume at those concentrations. What we're looking at is an indicator of where the plume may be present and predicting some of the behavior of it. So one of the things we need to look for is, that's why this comparison needs to be made, because it is correct. It is not an uncommon laboratory contaminant, but it's occurring in this data set at a higher frequency than what I see in other sites where we look for it, which is really where this has come from, is where the concern comes from.
What other sites are you looking at?
Laytonville landfill is one of the ones that comes right up because a lot of similar waste was put into that one. And I think that's probably the principal one that I'm looking at organics right now. And then we have several historical ones I've worked with over the last 31 years.
Okay, so Lakeville landfill.
What state is that in?
That's in California.
Okay, Dietrich, is that, or Dr. McGinnis, had your question?
I'm happy to send the request out. Thank you for making a little bit of time, Bonnie.
Okay, thank you. And I just have one more thing. I'm sorry, I'm pushing because our time was taken up, and we were supposed to talk about the response to Dr. McGinnis's white paper on the surface water. We haven't gotten to that either, so I'm going to try and synopsize this, and maybe we can talk about it more later. But the impression on the response, the EPA response on the surface water, is that it didn't address the points of the white paper. It merely rejected outright one of its conclusions without providing supporting argument. And I think we should demand the EPA respond to each of the conclusions, recommendations, and next step points that was supported by facts in the body of the paper. So that is one thing that we're requesting. The second thing is that as I read through this, the answers, I'm really confused, Linda, and I'd like to know if you could give me where I can find and what the page number is where it says you can freeze the ARARs. I've read through the ARAR directories and what we're supposed to do with them, and they're very, very important to a site. They're important for the state. And so I would like to know where we came up with this freezing. I'd just like to see the actual regulation, if you wouldn't mind. And then I just don't have time to go through our notes here, but I know on one line here it says that it is registered, it is reiterated throughout the document, CERCLA sites are exempt from administrative requirements of the MPDES stormwater regulation ARARs. I'd like to see a citation for where we can freeze ARARs and why that's a reason we can do this now. So it says, so technically the Lowry site is not required to submit a stormwater management plan. You know, technically it's not an ARAR, but we would like to see the plan. We just had so many comments on this that, so Linda, if you need me to send you an email with my questions, I'd be happy to do that. And,
sure. That would be helpful so I can make sure that I get them all. Yes, it's in CERCLA that Superfund sites are exempt from permitting.
Yeah.
And it's also in CERCLA that AROs are frozen at the rod. So I'll get you those citations for
Thank
that
you.
certainly.
Thank you.
Then to your initial one, you know, EPA did provide on October 9th our response to the surface water white paper, and it was 11 pages long. So Sarah couldn't make this meeting because of a babysitting issue. So hopefully she'll be available in January and we can kind of go through those 11 pages.
Okay, but hopefully we can plan a little differently than this tonight, because we're really frustrated because we also had Tom Krause's questions that he sent in, and we were supposed to we were going to try and do it rather quickly, but we still wanted to at least touch base, and we haven't. And then also on the list was the state officials delay water testing near Lowry Landfill Superfund site. We wanted to talk about that a little bit. We understand what it says, but at the same time, we're wondering, you know, the threat that's coming from the Lowry Landfill Superfund site is a Superfund issue. And the plume itself is just 1,000 feet west of Gun Club Estates. And so we're unclear why this has been handed over to the state to do. And we're wondering where the state's going to get the money to do this investigation. And since it is a Superfund issue in our minds, and we can argue that point at another meeting because we're already late stopping, and I don't want to lose more people, but we need to figure out, you know, where's the state getting this money? Why has it been turned over to the state to do when, as far as we're concerned, the question is the offsite plume a threat to the Gun Club Estates wells? So all of these, you know, all of these issues were supposed to be discussed tonight. And so actually, I have to admit, I'm a little upset that we didn't get to do it because I think they're important. Go ahead, Linda. Sorry, didn't mean to interrupt you.
Oh, it's gonna. So in January, our regional administrator wrote you a letter and answered many questions that you had in writing. And one of those was why it was turned over to site assessment. So that was January 2020 from Greg Sopkin. So it is the appropriate place for that investigation to be in. Based on the North End investigation report, there's not an indication that the plume from Lowry landfill is impacting those wells. So it is in the appropriate program. Colleen is the manager of that program. So she's been working on it very hard with our site assessment people. And so we certainly can talk about it in January at the meeting.
Okay. And
yeah, and just to clarify for you, Bonnie, the site
Yes.
assessment program is a CERCLA program that
Okay.
it is EPA, and then we are funded by EPA through a cooperative agreement. So we actually do the work and they review everything we do, and all of the reports are issued as joint reports between EPA and CDPHE. So it's EPA money that is given to the state to perform site assessments throughout the state.
Okay, thank you for that information. Now, my next question is, will the CAG be able to review the work plan?
The work plan for sampling?
Yes.
Yeah, so the way the process works, so we've done the preliminary assessment, and the next step is the sampling and analysis plan that we are still in the early stages of working on. And normally that isn't sent out for comment before the draft is finalized. Once it's final, it's absolutely open for public review. We would have to talk with EPA site assessment folks to decide whether or not it's something they're willing to have public comment on before it's final. So I can bring that up with them.
We'd appreciate maybe us talking about it at the next meeting, because what the CAG board has been saying to me when we discuss this issue is, if they don't think that that plume is a threat to the Wells and Gun Club estates, then let's do the testing and prove it's not. Because we do believe it's traveling in the wrong way. And if we're being shut out of the process because it's been handed over to the state and their program, then that's like, I guess Margie could say it better than I could, because she always says it. I don't like behind closed doors meetings and leaving us out of things, because then I don't know who to believe. And that's the way the CAG board feels right now about this being handed over to the state.
Understand, and let me clarify, the next step is testing. I mean, we have to write what we call sampling and analysis plan to put together the procedures of, and decide which wells and which analytes. But the next step is testing, and the delay for COVID is really based on the need to go out and do well-specific inspections to figure out sampling locations and, are there any issues with the well itself and that kind of thing. And that's where the COVID delay is really pulled into the equation. But the preliminary assessment is already complete. And in that preliminary assessment, there was a recommendation to go ahead and sample. So that has already been decided. And so the next step is sampling. It's just COVID is complicating the effort to sample.
Okay, I understand. Thank you, Colleen.
You're welcome.
But we do want to talk about this further, because we would feel more comfortable if Dr. McGinnis could help us review the sampling plan. But what we're hearing is that in this process, we're not allowed until after the decision has been made.
And I just want to make sure, I didn't say you're not allowed, it's just not normally done. And so I can discuss it with EPA site assessment group and see if that is something we can build in.
Thank you, Colleen.
You're welcome.
That's helpful. Thank you very much.
You're
Okay, does anybody else have something that they want to add at the end? I mean, we're already over. I'm sorry about that. I'm sorry we had to push on these issues. Oh, I have one. Linda, I did read Mr. Sopkin's response to us, but I'm still saying it's not really clear to me. So I understand what you're saying. It's just that there's more discussion that we want to have, and that's what we wanted to do tonight for our share of the meeting. So maybe we can discuss these things in January.
Okay.
Okay, thank you, everybody. I'm sorry we're late. Janine, thank you.
Yep, sorry we ran over, and sorry we ran out of time for your items, Bonnie. We will put those on the agenda for January, and we'll try not to let anything else get on the agenda.
And we'll be looking at some of the suggestions and requests that you guys made tonight, so that we can compile information and send it to you in the meantime before the next CAG meeting.
Yeah. All right, thanks all, and we will see you after the holidays.
Happy holidays.
Happy holidays, and stay well.
Night, everyone.
Night.
Good night. Thank you, Diane.
Good night.